So, real quick, what is meta-prompting? So it's basically using AI to improve AI prompts. It's creating a kind of self-refining system that enhances its own problem-solving capabilities. So essentially, getting the system to figure out its own intermediate steps and intermediate prompts. So you're prompting the thing to prompt itself during intermediate steps. So self-improvement process, and it's a continuous cycle of refinement there. So I think this was mentioned earlier as well. The inspiration here came from this paper from DeepMind recently around self-referentiality. And the problem is, handcrafted prompt strategies are often suboptimal. That point was made earlier. So the solution is meta-prompting, getting to some kind of feedback loops. So what we're going to go through here today and show is a Sudoku example where we're inputting a complex puzzle, and then the initial prompt kicks off the problem-solving process, and then the meta prompt comes in, and that's where we're experimenting. We're experimenting with various meta prompts that then kind of instruct the LLM to have a better, more guided process to solve the puzzle. So that's essentially it. The initial prompt is super simple, right? Solve this Sudoku, and only print the solution, no other text. And then the meta prompt on top of that. This is a kind of simple one. Refine the following instructions for an LLM solving a Sudoku puzzle. Make sure to make it better. So basically, just saying make it better. And then this is an example of the reformulated prompt that it comes up with itself. And some interesting kind of things that might say here, like, okay, you might need to make educated guesses at times, right? Okay, like here's what an accurate solution will look like for this type of problem, this type of task. So every time it kind of outputs a different formulated, improved prompt. So we have to do like a lot of testing and be really empirical about it. And then we tried another prompt here that was a little bit more specific and general, so not specific to the type of puzzle, but essentially kind of a generic problem-solving improvement meta prompt. And then so let's go ahead and see what those actually look like in reality.
Great, nothing like a live demo to see if it still can solve Sudoku. So essentially we are representing the Sudoku board. It's a 9x9 board, and we are, it has the digits between 1 and 9, and we use 0 for missing fields that it's supposed to fill in. So in the initial problem, it will have zeros at various points, and then in the solution, it will fill those in with numbers. So just to show you, so as I mentioned, essentially the puzzle is this array, and then the answer, you will see there are zeros in it, where it means we are asking it to fill it in, and then you can see how it has filled in some of these things. And it's actually surprisingly fast. So if I click run on this one, we actually we have been running it for 25 iterations. So I'm not going to show you all the way, but it's actually very quickly. Like first instructions, then it's already finding the solution. Then it's trying the next problem, already finding the solution. So it's actually, I find it surprising. It's definitely solving them at superhuman speed with very simple meta prompts in the end. So we ran them for 25 iterations. When we didn't use meta prompting, we got an answer which was around, I think here we can see 36%. And then we ran this meta prompt, and then we got an answer that, lo and behold, was 48%. So, massive improvement towards AGI. Trying to get there, but not quite. There's another lesson here though, where we're trying to be clever with our meta prompts. Let's try to really instruct the system with how should you search. We wanted to have sort of a very generic prompt that would say how to solve search type problems. And then the annoying bit was the performance actually went down to the initial prompt. What could this be? Of course, I'm going to refer to the bitter lesson. As a human, we think we are clever, but in fact, we may be adding the prompt in a vocabulary that is actually not so suitable for the LLM. So it's potentially the case that if you ask the LLM with a fairly simple meta prompt to generate the prompt, it generates a prompt in its own sort of vocabulary that fits it. Whereas if you're a human and try to be too clever and make a very long meta prompt, well, we don't get it to perform that well. So I think there's a lot more to be explored. Something which we didn't do yet is to do a meta prompt, to have a prompt that writes a meta prompt that And so it'll be very interesting to see, how far can you get when you try that. The code is out there for you to try. I think that's it, and we are very interested in your questions.